So, ladies and gentlemen, today we are not going to introduce any new topics. Rather, we are going to do some comprehensive problems to help us recap on everything we learned previously, including the rules and the formulas. Okay, so here we have three problems. The first one states that we need to differentiate y equals x squared times ln of sine of x. Now, the second one is that to differentiate y equal to e to the 2x powered divided by radical 1 plus x squared. And finally, for e to the x y powered plus y squared equals x plus 3, find the dy dx. Okay, so let's start with the first one. Okay, now immediately looking at y function, we realize that it's basically just x squared times ln of x. So it's just two terms times together. And in this case, we use the product rule, right? So therefore, y prime is equal to, now first differentiating x squared, using the power rule, x squared is 2x, okay? And then times ln of sine of x, we don't change this, okay? We write it at it is, plus, now we differentiate the ln function. Now, this function is actually just one function inside another function. Therefore, we have to use the chain rule, okay? So first of all, we differentiate ln of sine of x as a whole, and then we differentiate sine of x inside. Now, what's the derivative of a ln of sine of x as a whole? It is 1 over sine of x, okay? Times the derivative of the function inside, which is sine of x, which is cosine of x. Therefore, times cosine of x. Finally, times, don't forget the x squared here. So times x, sorry. Finally, times x squared, okay? So let me just simplify this expression a bit. So let's factor x outside, and inside we have 2 ln sine of x plus x times cotangent of x, okay? And so this is the answer for the first problem. Now moving on to the second one. Again, we first observe our y. It's pretty obvious that this is a function in fraction form, so we are going to use the quotient rule. So let's first differentiate the term on the numerator, which is e to the 2x powered. Now, first of all, we obviously use the rule for e function, and then we have to use the chain rule for 2x on the exponent. So therefore, we have e to the 2x powered times 2, because the derivative of 2x is 2, okay? And then times the radical 1 plus x squared on the denominator. We don't change nothing, so we write it as it is. Then we minus, now we differentiate the thing on the denominator. So we can rewrite this radical into 1 plus x squared to the 1 over 2 power. And so for this function, or for this expression, we can use the power rule, and we can use the chain rule, okay? So therefore, differentiating this, we have 1 over 2 times radical 1 plus x squared, okay, power rule. And then the chain rule inside, we have 1 plus x to the x squared. And what's the derivative of that? The derivative of that is 2x by, again, the power rule times 2x. Okay, and obviously don't forget the e to the 2x powered, so times e to the 2x powered, and all of this over radical 1 plus x squared, which is just 1 plus x squared, okay? And so all of this I did not really simplify, but all of this is basically the answer for problem 2. So let's move on to problem 3 finally. For problem 3, we see a equation which contains y and x on both sides. So it's not hard to realize that we need to use implicit differentiation. So let's get started. Now, the first term is a little bit tricky because first of all, we need to use the rule to differentiate function e. And then we need to differentiate using chain rule, differentiate the thing on the x-men, which is not just x or not just y, but x times y. And so therefore we have to use again the product rule to differentiate this. Okay, so let me explain. So here, differentiating both sides, we get e to the xy powered. We don't change that. Times, brackets, inside we differentiate this. So this is, the derivative of x is 1, so we have here 1 plus the derivative of y is dy dx, so x plus dy dx. Okay? And then back to our equation, differentiating y to y squared is basically 2y times dy dx. Okay? Equals 1 plus 0. The derivative of x is 1, and the derivative of a constant is 0. Okay, and now we need to group all the dy dx's, and therefore to do this we need to break this bracket. Okay, so breaking this bracket, we have y times e to the xy powered plus x times e to the xy powered times dy dx. Okay, plus 2y times dy dx, which is equal to 1. Okay, now grouping the two dy dx's, we get dy dx is, inside the bracket we have x times e to the xy powered plus 2y, okay, is equal to 1. Now minus both sides by e times e to the xy powered, we get 1 minus y times e to the xy powered on the right side. And finally, dividing both sides by this expression, we get dy dx is equal to 1 minus y e to the xy powered divided by x times e the xy powered plus 2y. And so finally we derived the answer for our last problem. So this session is a rather comprehensive session. The aim is just to kind of recap on all of the rules and formulas we've learned previously. So I hope you enjoyed today's video, and I'll see you in the next session.